this is Dr. Aruna working as Associate Professor in Department of Chemistry, Aditya University. Let us continue with the secondary cells, that is a lead acid battery. What is a lead acid battery? Lead acid battery is nothing but a secondary battery which consists of a rectangular ebonite or polymeric case which contains 5 molar sulfuric acid. So, once again we see that all the secondary batteries do have 2 electrodes and an electrolyte solution. So, this lead acid battery is also contained in a rectangular ebonite or polymeric case which contains 5 molar sulfuric acid, that is been selected as electrolyte. The anode is made of lead coated with spongy lead and cathode is lead coated with a spongy lead and lead oxide. So, here we can clearly understand that anode and cathode are been made up of lead, whereas the lead coated anode is been coated with again spongy lead, whereas the cathode which is made up of lead is coated with the paste of spongy lead and lead dioxide. So, here we have 6 such pairs of anode and cathode have been placed in series in a lead acid battery. So, here this is a battery which contains around 6 pairs of anode and cathode which have been placed in series. So, here we see the oxidation and reduction reaction taking place. At anode, where the oxidation takes place, lead reacts with the sulfate ions from the sulfuric acid to form lead sulfate and release 2 electrons. So, during the oxidation reaction, we see that lead combines with the sulfuric acid to form lead sulfate and giving away 2 hydrogen ions and electrons. And at cathode, the reduction reaction takes place where lead dioxide reacts with the sulfate ions and the hydrogen ions and electrons to form lead sulfate. So, here we see that at cathode, lead oxide combines with the sulfate ions and hydrogen forming lead sulfate and water. So, here we have the reduction reaction taking place where lead oxide combines with sulfuric acid, hydrogen ions and electrons to form lead sulfate and water. So, this is the reaction taking place at the cathode. So, the overall reaction during discharge is lead combines with the lead oxide in presence of sulfuric acid to change into lead sulfate and water. So, this is the overall reaction taking place during the discharge of electric current, whereas during the after charging we see the reverse reaction taking place where lead sulfate and water undergoes the chemical reaction to change into lead and lead oxide, giving back the sulfuric acid. So, here we have a clear picture showing the lead acid battery. So, here we have 2 electrodes, the lead which has been both of them have been made up of lead, as at anode we have lead oxide coated with lead oxide, and at cathode we have lead which has been coated with spongy lead and lead oxide, and here we have sulfuric acid and they have been placed in a polymeric case which has been mostly ebonite case, and in between the 2 electrodes we have the sulfuric acid. So, mostly we have selected polypropylene which has been used 5% and other polymer is been used. So, this is a construction showing the lead acid battery. Now, let us discuss its applications. Applications of lead acid battery are like this. First, we see that it has been used in automotive for the starting, lighting and ignition of vehicles is a primary application. So, this is the primary application of the lead acid battery which has been used in vehicles for the starting, lightening and ignition purpose. And it is also used in backup power, providing emergency power for critical system during outages such as a UPS system for hospitals, data centers and communication network. So, apart from being used in the vehicles, it is also used for the power backup systems, especially it is used for providing backup of power in hospitals and data centers and communication networks. This lead acid battery is also been used in energy storage, supporting the renewable energy systems like solar and wind power, as well as in grid and off grid energy storage. So this this battery is also been used in energy storage for supporting the solar and wind power, and especially the renewable energy systems like solar and wind power. It is also been used in energy storage. This is also been used in industrial and marine applications, power electronic forklifts, industrial machinery, and providing electricity for boats and marine equipment. So this battery has also been used in industrial and marine, especially in industrial machinery, and in the marine it is also used for providing electricity for boats and marine equipment. The other application is in telecommunication. So ensuring reliable power for telephone exchanges, broadcasting stations, and other communication equipment. So we see that this battery is also been used in telecommunication, especially in the telephone exchanges, broadcasting stations, and other communication equipment. So they are the applications of these are the applications of the secondary battery, that is the lead acid battery. Now let us discuss about another such battery which is known as a fuel cell. So we can consider fuel cell as the advanced cells. So first of all, let us try to understand what is a fuel cell. A fuel cell is a device that converts the chemical energy of a fuel, especially we have been using hydrogen, natural gas, methanol as the fuels. And an oxidant, as we know, as oxidant we have air or oxygen, which has been used to produce electricity. So once again we can understand that using a fuel cell we are going to get the electrical energy, and in a fuel cell we have the chemical energy which is been converted into electrical energy. So here we are going to use hydrogen, natural gas, and methanol as fuels, and for the combustion of these fuels, as we know, oxygen is very important. So in this fuel cell also, for producing chemical energy, we have oxidant, and this fuel and oxidant undergoes the chemical reactions to produce electricity. Now how this fuel cell is been made up of? A fuel cell has two electrodes and an electrolyte. So fuel cell consists of two electrodes and an electrolyte, and the fuel and oxidizing agents are continuously and separately fed into their respective electrodes, at which they undergo redox reactions generating electrical energy. So we see that in a fuel cell, the fuel and oxidizing agents are continuously and separately fed into their electrodes, at which they undergo the redox reaction generating electrical energy. So here we have a fuel cell where it is been represented as fuel plus oxidant, giving away oxidation products and electricity. So a fuel cell in general is represented as fuel separated by an supplied at the electrode, and in between the two electrodes we have an electrolyte, and on the other side we have other electrode where the oxidant is been supplied. So here we have a clear picture showing two electrodes, and the fuel that is been supplied at one electrode and the oxidant supplied at the other electrode, and we have an electrolyte in between the two electrodes where the oxidation and reduction reaction taking place, and hence due to this oxidation reaction we have electrical energy produced where the electrons are given, where they move from anode to cathode. So this is a simple representation of a fuel cell. Thank you.